Let's see if we can discover the connection between the function and its derivative. So the blue graph up here is the curve of the function x3 plus x2 minus 6x. And the black curve down here is the derivative of this function. So the derivative of this function would be 3x2 plus 2x minus 6. Okay. First, let's have a look at this function. We know that the derivative can be positive, negative, or 0, depending if the function is increasing, we have a maximum or a minimum, or decreasing, going down. So if we're walking around on the curve here, we can see that it's increasing. So we have a positive derivative until we come to the maximum. Up here we have the derivative is equal to 0, and then it's negative because the curve it's decreasing until we come here, the turning point in the minimum. The derivative would be 0 here, and here the derivative would be positive again because now the function is increasing. Okay, so let's see if we can discover the connection between the curve of the function and the curve of its derivative. Okay, so one thing for sure is that up here in the maximum and the minimum, the derivative is 0. So around minus 1.8, the derivative should be 0. So let's go down here, minus 1.8, it's 0. Remember, it can be a little bit confusing at first to look at this because you're used to looking at functions. So this is not a normal function, so to speak. It's the derivative. It's just describing if the derivative is positive, which means up here above the x-axis, and also here, and below the x-axis the derivative is negative. So here it's on the x-axis, which means that it's 0 because it's like we're thinking of the y value. Okay, so if the y value up here is negative, the y value down here is negative, y value is 0, y value is positive. So once again, let's have a look at the function. Up here we know in the maximum we know that the derivative is 0. So for about x is equal to minus 1.8, which is here, it's 0 because the y value here is 0. Okay. Then the other 0 would be when x is about 1, maybe a little bit more than 1. It should also be 0. So let's go here to the curve, the graph of the derivative. When x is a little bit more than 1, the y value is 0. So we have another 0. We can see that between x is, so when x is minus 1.8 and let's say 1.1, between here we have a negative derivative, and that makes sense because between the maximum here and the minimum here the function is decreasing. Okay, so that makes sense. So between this point when x is about minus 1.8 until here when x is about 1.1, the derivative would be negative. Okay, before to the left of x is minus 1.8, it's positive because it's increasing, and we can see here if we go to the left of x is equal to minus 1.8 is positive. Okay, Also, to the right of x is equal to 1.1, the function is increasing again, it's going up. Okay, that means that for every x value to the right of x is equal to 1.1, we have a positive derivative. Okay, and we can see here in the graph the y value is positive. Once again, at first it can be a little bit confusing to compare the function and its derivative in the same coordinate system. I just have two different here. We're going to have a look at some examples soon. But just try to draw the graph of a function and its derivative and see if you can kind of connect these two, if you can see how they work together.